Okay, so we want to graph this function. As with all of the others, I am going to refer to my checklist. Like I always say, this is really helpful. I encourage you to reference it. Keep a version of it that makes sense to you handy, so you can graph. So to start us off, again, remembering that these first two go together. So we are going to work on them as a group. So we're going to do that by setting our denominator equal to 0. Number 1, number 2. If x plus 1 is 0, that means x is -1, right? So this is a vertical asymptote. It also means that that number is removed from our domain, so everyone except -1 is included in our domain value. So our domain is -infinity to -1 union -1 to infinity. So again, the only number we are not allowed to plug in is -1, and that's because if we do, our denominator becomes 0, right? So it becomes undefined, so it's not helpful to us, okay? Next up, let's look at our horizontal asymptotes. So HA, and again, we always check for these first, and then we backtrack to obliques if we need to. So in this case, we're focusing, like I said before, we're focusing on our leading terms in the numerator and in the denominator. So we've got an x squared up top and an x in the bottom. So now this one is larger and this one is smaller in degree, right? 2 is larger in degree than the invisible 1 right here. Well, in this particular scenario, there's no horizontal asymptote. So in this case, there is none. So we want to check for the oblique asymptote if there is one. Now, the one we did earlier was a pretty kind of nasty example. So let's try it again. I promise it'll be a little smoother. You divide your denominator term into your numerator term. So we would say x plus 1 goes into x squared, and you could actually use synthetic here. Remember your formatting changes, so it would be a -1, and then we would use our coefficients. So that's for x squared, that's for x, that's for my constant. So this comes down, drop the 1, right? Times -1, we add, and then times -1 again, and we add as well. But remember that this is our remainder, and we pretty much just ignore it, right? So the quotient that we're left with here, and this represents our oblique asymptote, is y equals, remember we go down a degree, so down from the squared, this becomes x minus 1. So I'm not trying to say that divides evenly or anything like that. This is just our process for finding an oblique asymptote. We are still going to graph this, and when we do, we're going to use y is mx plus b as a guide. Let's actually start our graph. We have plenty of information at this point, right? So let's sketch it in. Y. Okay, so what do we know so far? Well, we already said we have a vertical asymptote at x is -1. So let's graph that. Here, -1. We're going to sketch that in. This is a vertical asymptote, right? So I'll label it VA. And then we have this oblique asymptote, and that's kind of new for us, right? So in this context, we start here at that b value 0, -1, right? That's your intercept. So that's right here at y is -1. So this is my first point, right? My second point is going to use the slope, right? Slope is 1, and you could put it over 1 if you want that rise over run. So rising 1, run 1 that way. So if we rise 1, run 1, we're here. I could do that as many times as I want, really. You can rise 1, run 1, end up here, rise 1, run 1 here. That gets a little dangerous if my spacing is a little off, but hopefully it's not terribly off. hopefully we're okay. So this does the same thing that all of our other asymptotes do. It's just a little different in how it's formed or how it looks. But do you see those two boundary lines that we've formed? And this is an oblique asymptote. Now, we did this with our other questions. It is worth checking if it crosses. And again, like I've said many times, it's not common. So if it doesn't cross, that's totally fine with us. We'll say, does it cross? Does f of x cross our oblique asymptote? Well, there's one way to find out. Take your function, x squared over x plus 1, and set it equal to x minus 1, right? That's our oblique asymptote from up here. So I'm going to cross multiply again. I have x squared is equal to, and we need to FOIL this out. This is the difference of squares, right? So you get x squared is x squared minus 1. If we move those x squareds together, we end up with 0 is negative 1, which again is false. So does it cross? No. Again, if it did, so say it crossed it, you solved and you got x is equal to 2. If that was the case, then you would find where x is equal to 2 on your graph, and this would be the point where it crosses, right? Because that's 2. It's not. I made 2 up, but I'm just giving you an idea of what this would look like. Okay, so we've done quite a few things so far. Let's check back in with our list. And another value to this list is, you know, sometimes our processes can get kind of lengthy and it's easy to kind of get lost within your question. So if you have this to kind of ground you, it can be really helpful. The next thing we want to do is find the zeros of our numerator, which should be really straightforward because it's just that one term, right? So let's look at number 4, zeros of our numerator, which translates to our x-intercepts, right? So this, our numerator is x squared equal to 0, means it's where x is equal to 0. So your x-intercept is that ordered pair 0, 0, which we can graph. I'm going to graph it in orange since I've been graphing most of my points here, right? That's our x-intercept. That should also translate to our y-intercept, which you're always welcome to check, right? So our y-intercept should be f of 0, which is 0 squared over 0 plus 1, which is 0 over 1 and definitely 0. So not super surprising. It's also 0. Okay, in order to be a function, you're only going to have one of those. You're not going to have multiples. If you remember our vertical line test from the beginning of the semester, pretty close. So does this give us enough to sketch? I mean, we have these boundary lines, but other than that, we only have 2 points. I would say probably not. Maybe we can get a little more definition. Could we maybe plug in 1 right here, or 2 or 3, or just something to get a little more of an idea? And if we have to, maybe even a fraction that lives back here, just so we can get some idea of what's going on over on this side, right? The whole idea is just to get some visuals, right? Okay, so let's do that. Let's plot some points. So x, f of x, we've got x squared over x plus 1. I'm just going to work with some of these numbers right here. We can backtrack to some of what's over here later. There's not really an order to it. Let's plug in 1. So f of 1 is equal to 1 squared over 1 plus 1, which is 1/2. So f of 1 is 1/2. That's kind of like right here, right? Maybe a little closer, but right about there. What about 2? So f of 2 is 2 squared over 2 plus 1, which is 4/3. That's a little bigger than 1, so maybe like right here. So it seems like we're pretty close to this line. What would happen if we plugged in 1/2, negative 1/2, excuse me? That would be this value back here. So f of negative 1/2 would be negative 1/2 squared divided by negative 1/2 plus 1. Well, on the bottom, that's just a half, right? And this is a fourth. So 1/4 divided by 1/2 is 1/4 times 2 over 1. That's a positive 1/2, right? So again, just for some idea of what that looks like, it's a little high. Something like that. So that actually gives us some pretty good view. Remember, we will never, ever, ever cross a vertical asymptote following that line and going up that way. Now, again, it's kind of hard to tell, do we have a graph up here or is it down here? Where else do we have points? Again, just use your table, right? I don't think we have the same symmetry we did in the last question, so we may not be able to recycle values quite as easily. But maybe if we plug in like, so this was 2, that was 3, maybe like a -2, a -3, maybe even a -4, we'll just see how many we need to see the full picture. I find a lot of times students are just, they don't want to do a couple extra points. It's like, you do 2 and you're tired or something. So just push through, do a couple more points. It'll be beneficial in the end. If we do a -2 here, f of -2 is -2 squared over -2 plus 1, right? So that's 4 over -1 or 4, -4, excuse me. Let me draw a line here. -4. So over here, we've got -1, -2, -3. This is -4. So at -2, we're right here. At -2, we're right here. So it's pretty clearly below that green line, that green oblique asymptote. Let's plug in -3 just so we have a clear picture. -3 squared, -3 plus 1, that's 9 over -2, which is 4 1/2, -4 1/2. So a little lower than that, but not dramatically, right? And you could plug in fractions. I won't make you do this, but like -3/2, that would be this kind of middle point right here. And I suspect you would get some more values, maybe even like right here as well. So I think it's kind of a mirror image. You can always plug in more points, like I said, if you need more to kind of figure out what it looks like. So it's a pretty weird graph by comparison, but that's it. That's this one. All right, we have one more. We'll look at it right now.